Hi everyone, welcome back to another video. So we have some idler wheels from a little tractor to sort out today. That takes a bit of saying. Tractor. So I'll insert a picture now so you can see what they're off of. Yeah, it's a little tractor with tracks on it, and they use it with a dribble bar on the back, and then they pull like an umbilical cord behind it to spread slurry onto grassland, I think. So yeah, this is like the frame that the wheel sits in. Like that pin goes across from one side to the other, and then the wheel spins round in there, and that pushes out to tighten the track up. But the issue with them is the bearings have disintegrated, and they've not noticed, and then it's sort of chewed everything up and sort of destroyed everything. Now that one's the worst one. This one, they've managed to catch it before it's disintegrated altogether. I think the shaft or the pin is bent. Yeah, you can see it's bent there. So they have managed to source some new ones, but the diameter is too small. Like, they're a lot bigger than what they are. I think the centres, everything in the centre is the same. It's just the overall diameter on these is a lot smaller, and they're not as well made either. You can see how thin they are there compared to these, and these have got webbing in. But I don't think they could find any new ones the right diameter, so yeah, I'm gonna have to sort them out. Now, I said they didn't pay a right lot of money for these new ones, so by the time I'd made all these new pins, these new shafts, and all these like outer bits are all chewed up and knackered as well. So yeah, for the price I paid for them, rather than send them back, I think if I can take all the internals out of them, use the shaft and like them end caps and the bearings maybe, and yeah, take all the middle out of them and put them into these, it'd be cheaper than me trying to remake everything. So yeah, that one, so it shouldn't be too bad because it's still sort of intact, but this one, not good. So first job, I'll have to take these bearing races out, and then I can see what we're sort of left with. So I'll have a bit of a go at knocking them out first, and then if they're not going to move, I'll run a weld around the inside of them, and then when the weld shrinks, it like shrinks the bearing race, and then they should knock out easier. So I got them knocked out from the bottom side. I tried to knock these out, but they wouldn't move. But now I've taken a bit more notice. I can see there actually is a circlip in there still. So I'll take that out. There wasn't one in the other side, where it must have got chewed up or it's come out. I'm not sure, but you can see the circlip groove is there, but there was no circlip in it. So yeah, I'll get that out and then they should knock out. Right, so I've had a bit of a go at that circlip, but I don't think there's much chance of me getting it out because it's fairly mullered. There's no hole left at that end of it, and it's just sort of been, yeah, it's just been mushed. So I think I'd maybe just try and cut through it with a gas. I think try and melt the circlip out, and then either melt the bearings out as well, or if I can get that circlip out, then we'll try and knock them bearings out. Right, so that's a circlip out. So I'll turn the wheel back over now and then we'll knock them bearings out. so we've got all them bearings out now. That wasn't too bad once we got that circlip out. Knocked out fairly easy. Yeah, you can see this, the side that didn't have a circlip in, you can see the groove has sort of been mashed up and worn away, so yeah, the circlip will have come out. That's why there wasn't one in this side. So yeah, I've got to work out now the best way to sort of build that back up again to make that sort of look like this one. Take this one in bits now. I'll take the bearings out of this one, see what this one's like, give it a good clean up, see if there's any work needs doing to this, and then I'll take a new one in bits, and then we can have a look inside there, see whether them bits will be interchangeable with these. So that's the bearings knocked out of this second one as well. Now this side doesn't look too bad. I'm just going to turn it over again and clean the other side up, see what that looks like. Yeah, so this side is not as good. Sort of worn that lip off there and it's a bit chewed up inside there. Where the bearings go is fine on this one. And on the other one, it's just where the circlip goes. But yeah, this sort of needs to be right, otherwise it won't seal up properly. So yeah, I'll take a new one in bits, see what's inside there and see what that looks like, and then we'll decide what to do with these. Right, so I've got this one off. I forgot to press record, but so that cap goes on, then there's a circlip that holds that on. Then when that comes off, inside there's a big O-ring that goes in there. Then there's this ring that goes over there and sits into that O-ring and into there. Then there's another one of these, but the opposite way, so they're like back to back, like that. And then on the inside of there's another O-ring, which goes into there like that. And then in there is a circlip that holds your bearing in, same as what they were. So I think I'll turn it over, tack all that out the other side, and then see if I can get this shaft out. When you look on the old shaft though, it has a shoulder in the middle. So like the inner race of the bearing will have to come out as well before the shaft will come out. Right, so I've got these top bearings knocked out, come out on the shaft. So there's two bearing races there. That's another bearing race, and then don't know where the other one is. It must be still in that bearing. That's top floor there. Yeah, so that's them. So I've taken them off. So now if I turn that over, take the circlip out on the other side, and then use that shaft to knock the outer race out, outer bearing. And then we can decide, or we can see whether all that new stuff will fit into them old ones. That was easy. I've got this one just held in the vise now on the bench. I'm just deciding what to do with it. So yeah, it's too damaged to hold a circlip. I'll have to do something with it. But I've just tried that shaft in there with these new caps, or new, caps, whatever you want to call them. And they will fit. The only thing is the shaft is a little bit longer than the original one, and the bit in the middle, the shoulder, is wider, so I'll have to take a bit off that shoulder. Otherwise, when I put it in the bearing, the inners won't line up with the outers because there'll be a smaller gap between the outer races. So I'll have to machine a bit off there, and it's a bit wide where it goes into the jaw on there, so I might have to make some spaces or turn a bit off there and add a bit more thread on. But I don't think I might have. I don't know if I'll have a way to thread any more onto there or not. And they were just filled with like gear oil as well. There weren't no grease, it was just gear oil. So once the oil is leaked out, there's nothing to lubricate the bearings. So whether I can put a grease nipple on there instead of a grub screw, I think that must be where you fill it with oil. Anyway, yeah, I think we'll see if we can fit this in the lathe. You think when people would bring stuff into repair, they'd wash it off first, wouldn't you? It's all still covered in slurry. But I think what I'll do first is I'll just put a bit of weld on it somewhere and make sure that I think it's cast steel. by the look of how it's like burred that over rather than snap off, I'd have said it would be cast steel. But we'll have a little test, see what it's made out of. Have a little weld test, see if what it will weld like and whether it will machine back down again before I put it in the lathe. Right, so I just did a little bit of weld on there just to see what would happen, and it's gone extremely hard. It's just blunting my chisel. So yeah, I can't weld that with normal MIG wire. I have some nickel rods. Might see what they work like. That's why I always have to test first before you. If I hadn't have tested it and welded it all up with that, then I'd have been in trouble. So yeah, you always want to test it first. Right, so I've cleaned off another patch. I'll have a go now with these nickel rods, Super Cast Ultra. See what they go like. I'm going to use a little Jasic again. Well, I said before, Jasic gave me this welder for free, but they're not paying me to use it. There was no deal on using it or whatever. I'm just using it because I think it's a good little welder. So yeah, I've got that on stick mode, set at 80 amps. See how that goes. So I've just done a little run on there. You can see now I can actually mark that with a chisel. It doesn't blunt on my chisel, so yeah, we'll use that. Should be nice to machine back down again. So I think when you try and weld it with normal MIG wire, I think it draws the carbon out into the weld and makes it really hard. But then when you weld with nickel rods, obviously it doesn't draw the carbon into the weld the same. So that's still soft. Yeah, so I think I'll get the 4-jaw chuck set up in the lathe. And I'll be able to hold it, obviously, on the other side, but I'll be able to hold it by the hub. And I'll maybe put a draw bolt through the middle as well to hold it in. I was thinking I could maybe hold it by them, but my jaws are not going to be deep enough to reach to there because of the hub in the middle. So yeah, I'll get this chuck taken out, get the gap taken out, and then we'll put the 4-jaw in, and then set it up in the lathe. So I've given that a wire brush off and got some of the slurry off it, and I plasmed 2 of these washers out. So one will go in there like that, with a bit of threaded bar through there, and then the other washer will go on the back of the spindle on the lathe, and just help hold it in, and then 4-jaw will clamp around there. So yeah, we'll get that put in the lathe now. Right, so I've got that in the lathe now. So I've got that threaded bar through the middle. Comes out there, so that's holding that in. And then I've also got it nipped up in the 4-jaw as well. And I've trued it up, and that'll be near enough. A little bit of a wobble there. I've trued it up off the bearing face. And it's I'm only doing the circlip groove anyway, so it doesn't need to be absolutely bang on, so that should be near enough for that. So yeah, we'll bar that out now. And I think I'll just bar that out, yeah, up to the circlip groove. Yeah, I'm not quite sure. There's a bit of a taper on there as well for where that O-ring runs. But anyway, we'll take a few cuts, clean it up and see what it's going to look like. Right, so I've got that cleaned out. I've gone sort of 2mm deeper than like the surface. So when I put some weld back in, there'll be 2mm depth of weld. And I've cleaned that out a bit up as well. And I've also, there's a bit of where it had worn, it had put like a chamfer on it. So I've just gone over that, cleaned that up. I don't want to take too much off because it would take a lot of building back up otherwise. Now this probably could be a job to weld, to like spray weld back up, but I haven't got a a spray welding torch. I was in the process of pricing one up, but then there's that many different powders you use for different jobs. I wasn't sure what powders I'd need, so I never got around to actually ordering one. At least with them nickel rods, I've used them before and I sort of know what I'm doing with them. So I think they should do the job. I've put one in already, like a band. It's like that pallet strap, metal pallet strap. I've made a band to go in where the bearing is. I'll put another one in so I don't end up with splatter and stuff on the surface where the bearings go into. Right, so we're about ready for welding, I think. There was a few bits I've diagrammed out that were, I've sort of had rust in the bottom. So I've diagrammed them out and I've gone around there with the grinder to clean that up because I'll have to sort of build this edge up as well. So yeah, I think I'll give it a preheat now to sort of 200, 250 degrees C, I think, something like that. And then just weld it away, steady away. Right, so I've got that built up a bit. I'm not quite sure whether I've got it built up enough yet or not. Yeah, it doesn't look very nice. I don't know whether it's because of my lack of skill at stick welding or whether it's just not very nice stuff to weld. But I never really need to do any stick welding, so yeah, I'm not very good at it really. So I might let that cool down a bit and then, well, I'll let it cool down. I'll machine a bit out of it and see if we're going to have enough. If we're not going to have enough, then I'll have to build it up some more. Well, something new came today, well, it came this morning. I've been absolutely dying to put it together all day, so I wanted to get on with that wheel and get a bit done with that. But anyway, I'm going to bring it in and put it together now. Right, so this is a brand new 3 meter 1500 Siegmund 8.7 fixture table. It was all wrapped up when it came this morning, but I've unwrapped it and I've had a look through all the boxes and had a bit of a play with it. Well, yeah, we're going to get it out of its wrapping now and put the legs on it and put it together. This will replace this workbench. I mean, need a good tidy up. But yeah, that should take fabrication to another level. I'll get it unwrapped and get it put together. Right, so that is that all built up. Legs are on. The hardest part was putting that cabinet on. I took the brackets. If I read the instructions, it'd have been simple, but I didn't read the instructions. Anyway, it's all on now. So yeah, it's pretty nice. So it came with like a tool set came with it. So there's 6 of these clamps that like press straight down, and you can alter them, and then there's 2 of these that are on an angle. And then there's 4 of these sort of squares, 4 of them, 6 of them. There is some, I think they're in this drawer actually. So how many of them is there? 12 of them. These go. You have to do like that and you tighten them up. Then you use them as stops. And they've all got measurements on them, and they've all got scribe marks on the bench, so you can set them all the same via them numbers. There's also numbers scribed all the way down the bench, all the way down the table. Yeah, some of these, I don't really know what these are for. They're magnetic as well. I don't really know what they're for. And then there's two of these squares with holes in, and then two of them bigger squares as well. And I think that's to put your welding torch in. You can move that wherever you want it. There is all sorts of other different add-ons and squares, and there's a full catalogue of stuff you can get for it, but that's just sort of the basic kit that it came with, just to get you going. Well, yeah, it's very nice. It's 3 meters long and 1500 wide, or 1.5 meters wide, and it's a Siegmund table, and it's an 8.7 extreme is the make of it. So it's, I think the top's made out of tool steel, it says, which is like, well, it varies. They mill it flat, so it depends how out of flatness it was before they milled it. So I think it's like 25 to 27 mil thick, I think it says. And the sides, S355, I think. And when you look underneath, there's quite a bit of bracing underneath. So it should be nice and strong. And as you can tell by the amount of stickers it has on it, I got it from Mesco. There's 25 of them stickers altogether. Must have used up the sticker budget for the year on this table alone. So yeah, very pleased with that. Just need a job. Well, I've got plenty of fabrication jobs lined up to use it for, so it'd be good to try it. Yeah, and this is going to go where my old bench is once I've got tidied up and that moved out of the way. Right, so this is completely cooled down now. Well, it's a different day today, so yeah, we'll have a go at machining this out and see what we're left with. Right, so I've got a bit of machined out of there, but I haven't got enough weld built up yet. So it's like still 2 mil undersized, so it wants another 2 mil taken out, but yeah, it's not going to get to the bottom of that weld. There is a bit of a taper on there as well, but still it needs building up like out this way as well. And then some bits in there where it's building up. Again, doesn't matter too much in there because it's only a circlip groove, but just doesn't look very good. So I'll build a bit more up in there and then build all this back up. I built that back up again now. Hopefully that'll be enough. So that's cooled down. So yeah, we'll machine that back down. Hopefully I don't have to add any more to it. Right, so I've got that machined out now. I've tried the O-ring in there, that's why it's a bit oily. But I've put a 10-degree taper on there as well. So yeah, we're a bit short of weld in there still, but it won't have to matter now. We're a bit short of weld around the outside as well, but again, it won't have to matter. So yeah, I need to cut the circlip groove in there now. I have this tool for cutting internal circlip grooves, but I think I only have one insert for it, so it'll be a miracle if I manage to get this circlip groove cut with that one insert, because it's pretty tiny. Right, so that is that done now. I've got the circlip groove cut in there. So it's not perfect, but it's a lot better than it was. At least it will hold the circlip now. A few bits like there. Well, I have machined a bit off the top, but I'll do that with a bit of a sanding wheel, I think, just where I've overshot it with weld. I've taken them bits of like pallet strapping out. So yeah, not perfect, but it's at least now it will hold a circlip and it's not all chewed up where the O-ring goes. So I'll get that lifted out again and then we can start putting this one back together.
No, that'd be weird. We've used anything recently.
Yeah. Hopefully all the bearings and everything fit together the same.
And another one to do as well.
Well, no, that was not as bad as that.
Alright, okay, we'll swap the bearings.
Right, so I've got that lifted out. You can see the other side is not very nice really. That wanted sorting as well, but there's going to be a lot of time again doing all that, so we'll see how it goes as it is. I think that's the side I've just done. So to put these bearings back in now, I'm going to use the new Siegmund table. So there's these squares here that you can use as like outriggers. So if I put them on the side, then I can stick the wheel onto them, and then rather than working on the tines all the time. So we've got the wheel clamped on there now. I'm just looking at these shafts now, so I've got it mocked up with the old bearings on and how it all fit together. The circlip going in the end there. When you look, that has got a lot wider like shoulder in the middle than what that one has. That's like 10 mil, that's about 17 mil. So yeah, I need to make this shoulder the same width as that one, otherwise the bearings won't line up. And if I do that, the circlip groove isn't going to line up, or there's going to be too much slack, so I might have to put a washer behind there because I haven't got a tool suitable for cutting a new circlip groove on like the external. So yeah, I'll get this shaft set up in a lathe and then turn that shoulder down to the right width. And the shaft itself is a little bit longer. You can see there and there, its overall length on this new one is longer. So I might be able to put some spacers behind this plate, maybe, and make up the difference with spacers. Right, so I've got that trued in. I said that was near enough. In fact, it's nearly bang on. Tiny bit. But yeah, that'll do. So I think I'll use the parting tool and just slice a little bit off of either side. I've got that shaft machine down, the shoulder machine down. So I was going to use a parting tool. Well, I forgot to press record on the first half, but it was quite hard and the parting tool didn't seem really like it wanted to cut it very well. So yeah, I did that side with that tool, and then I swapped over to like a left-hand tool to do that side. So that's got that down to 10mm now. So on this wheel, I'm just going to give them little bits of weld, a bit of a clean up with a die grinder. It just wasn't quite true enough in the lathe to machine it off. You know, it wasn't absolutely bang on, so if I tried to machine them off all the way in the lathe, I'd have taken a bit more off one side than the other. So yeah, I'll just smooth them off the die grinder. Right, so I think we can start reassembling this now. So one of these end caps has a grub screw in it that goes all the way through. I think that grub screw is just to stop this cap turning. But what I'm thinking with that, I'm guessing that is so you can fill it with oil once you've got it all together. It's just had like gear oil in to lubricate the bearings. But once all the gear oil is leaked out, then the bearings are getting no lubrication, and then that's when they fail. So I didn't know whether to take that out and put a grease nipple in there and fill the wheel up with grease rather than oil. And then at least it is, you know, you can pump more grease into it. And grease is less likely to leak out as well. I can't see why these wouldn't run in grease any different to like a taper wheel bearing. So they're only Chinese bearings as well. So yeah, we'll try that. I think we'll try it with grease rather than oil. Got my grease gun already clamped down there ready, so I can pump some grease in. So yeah, we'll start putting it back together now. So it was just a little bit tight was the bearing. I think I'd maybe got it in a little bit, not quite straight, and it was being difficult to knock in. So I just put the hollow jack on it, and it's only just lightly pressing it in. Right, so I'm just having a bit of bother with this circlip. Made a bit of a balls up with the circlip groove. Obviously, I haven't come far enough this way with the groove because I can't get the circlip in properly. So I didn't really have much to reference off when I cut the circlip groove. I was just sort of referencing where I could sort of see where the old one was, where I hadn't quite got it filled up with weld. And I thought I'd come far enough this way, but anyway, obviously I haven't because that won't go in properly. Now, you can knock it in with a chisel at one side, but you still won't go in very well at this side. And I want it to be right because if the bearings ever need changing and then someone else comes to put the circlip in and it won't go in, then yeah, it's not going to be right. So I'll take that back out. I'll have to put this wheel back in the lathe and make that circlip groove a little bit wider. I think what I'll do first is I'll take this other wheel in bits, machine the shaft down on that, machine the shoulder down on that shaft, and then I'll put that wheel together, the one that I haven't altered, make sure everything's going to fit all right before I start altering, before I put this one back in the lathe again, because it might need a little bit more taken out for that O-ring or whatever. So yeah, I'll get that one put together first, and then we'll tackle this one again. Right, so I've got them bearings in at that side. Now that inner's dropped down, but that goes in there. So I'll get these inners in, well these, I've got one inner race, so the 2 outer races are to go in now. I think I'll fill that middle bit up there with grease first before I put them in. Right, so that is all the bearings in and the circlips in now. Yeah, they all fit in, nice. So where the O-ring goes is not very clean really, but I don't think that circlip turns in there. I think that is just sat in there like that, and then these like mechanical seals turn against each other, and that's what does the sealing. So, and because I'm putting grease in there rather than oil, I'm not too concerned about, you know, it not being perfect where the seal is, because yeah, its grease is a lot thicker, provided it don't get water in. So yeah, we need to try and get these back in and squash all that lot up now, and then get the circlip back on the other side of that cap. So I've got that clamped down now, squashed down, and it just wanted a spacer to go in there now because of when I machined that bit off the shoulder. I used the first shaft that I did. Obviously, I haven't got this one machined down yet, but when I machined like 3.3 mil off either side, it means I've now got that here instead. So that's why I'm left with that gap. So I nearly wanted a little spacer or something in there before the circlip goes on. So I might have to make something to go in there. Just take that back off again because I forgot there's an O-ring that goes on that shaft. Right, so I've just machined 4 of them. I didn't video it because it's just simple lathe work, but just, yeah, machine them to size and then parted them off. I've already got that one put in there now, so that's that all nipped up like it should be. It's just, yeah, it's worn a bit off there. Would have been better if that wasn't as worn down, but it should be alright. So I'll turn it over now and do the same on the other side. That one is all back together then. I took that grub screw out and obviously the seals are working because there was pressure inside it, so it's sealing up anyway. So yeah, that's the one I might put a grease nipple in, depending on how it fits together back in there. I might not be able to get a grease nipple in it because of the plate on the end. So yeah, that's that one done. We'll have to go back to this one now, machine that circlip groove out a little bit more. Right, so I've got them bearings pressed out again. They're a little bit too tight really. So when I put them back in, I'll go around the inside of the hole with the sanding wheel on the die grinder. Just clean it up a little bit. So yeah, that needs to go back into the lathe now, and then we'll make that circlip groove a little bit wider. I think before I do that, I'll machine this down on this shaft, because that needs to be down to 10mm, same as the other one. Right, that should do it. So I've given the circlip groove another 3/4 of a millimetre, so should be good at that now. I've double checked, measured from the face of there down to there, and we've got a tiny bit of clearance, so yeah, that should be better. Should have done that to start with really, but yeah, I didn't have much to reference off where the circlip groove needed to go. But anyway, I could have measured it like I've done now. But anyway, yeah, that's done. So take that back out and get them bearings put back in. Right, so see how them bearings fit in now. See how the circlip fits in now. Yeah, Esco have also given me a discount code for anything Siegman on their website. So if you're after any clamps or even a table, if you use the discount code Snowball, they'll give you 10% off. So that's on the Esco website, which I'll link it in the description. Right, so I've got a circlip in now. That's better. The bearings are still a little bit tight, and tighter than what that one was. So whether the heat has shrunk it down a little bit. Anyway, they're in now. Right, so there we are. That one built back up again. So it's actually better, that one, where I built it up, than that other one. That's all right. That's good. Just that one's a little bit worn across there. As long as you don't get any band or anything in there, it should be fine. So yeah, that's both of them back together. So I think I might have to make some spaces for that, but I'll sit that on the tines. I'll lower this wheel in and see what spaces it needs. Right, so I've got that in there. It is a little bit tight fitting in there and there, but it does spring out enough to fit it in. What I've noticed though is the end of these shafts are only 35mm, where the end of the old ones are 40mm. So I might have to make some like adapters up, some like collars to go onto there to make that up to 40mm, otherwise it's not in the middle. And also, yeah, the shaft's a little bit longer on there. Means these plates won't go on properly because there's, you know, that gap, that shoulder. So I'll have to make some spaces to go in there, I think, and then yeah, some collars to go in there. But yeah, you get the idea anyway. So there you go in there. That's what them grub screws are for, is to stop the cap from turning. Just, I don't know, I might have to drill and tap a hole in there to get a grease nipple in it, because I was hoping I could use that grub screw, but you sort of can't get at it. But unfortunately, I've run out of time this week because I'm going to Duncan Park Steam Early this afternoon and I need time to edit the video, so I haven't really got time to do any of them last jobs. But yeah, anyway, you've seen that one put back together. That's the one I repaired. So it's not perfect, but it does the job. It holds a circlip now. New bearings in, new caps in, new shaft. So yeah, that's that sorted for now anyway. So yeah, that's it for this video. Sorry I haven't had time to properly finish it, but yeah, it's run out of time. Yeah, don't forget, ESCO, discount code Snowball, 10% off. So yeah, thanks for watching and I'll see you next time.